Okay, Bismillah ar-Rahman ar-Rahim. Alhamdulillah Rabbil Alameen. Good evening, everyone. Thank you for joining us on tonight's session. Tonight we will be focusing on an in-detail deep dive on the lead credit categories for V4. Tonight's session title is Lead 201 for V4 Core Concepts and Strategies. I'm sure most of you know the housekeeping rules we talked about yesterday. Please keep your mic on mute. Q&A sessions will be at the end of each module if we have time. But please post your questions in the chat box, and we will hopefully be able to answer them all. For those of you who are joining us just today, just a brief introduction. I'm Mohammed Al-Sarf. I'm the Regional Manager for GBCI Middle East Markets in KSA. Joining me today is my colleague Deepti. She's the Regional Director, Market Transformation Development, GBCI Middle East Markets. And our Managing Director, Mr. Gopal Krishnan, who is the Asian Pacific region for GBCI and the Middle East. Deepti.
Hi, welcome everyone. Thank you so much for joining us. I hope you enjoy this session with us. Thank you.
Thank you. Okay, so basically we're covering GBCI Middle East, ranging from the UAE, Saudi, Oman, Bahrain, Kuwait, Jordan, Lebanon, Egypt, Qatar through ongoing projects, and supporting also Northern Africa. Yesterday's session was on the basic level, 100 level awareness, which was the lead 101. Today's session is going to be the beginning of the understanding levels to the lead credentialing exam for the lead green associate. We're going to begin tonight with the lead 201 session. Further sessions can be later on scheduled for higher credentialings for building design and construction, and other APs, but also we'll be sharing some details on USGBC faculty who can also conduct these workshops, and you can connect with them, and we will share their details by the end of this presentation. Just some copyright information. This presentation is protected by US and international copyright laws. Reproduction and distribution of this presentation without written permission of the sponsor is prohibited. Okay, so what we're going to learn today, basically what we learned yesterday was a very basic topic on the lead system. Tonight we're going to have a detailed description of the structure of a lead rating system. You're going to be able to describe the lead certification process in detail, describe key lead green building concepts and goals, recognize successful lead strategies and metrics. Also, to describe the role of the integrative design process, in addition to identify synergies between credit categories and strategies, and describe case studies of lead best practices in action. So this is just a summary snapshot of what we're going to cover tonight. We're going to go through the location transportation category first, followed by the sustainable sites, then water efficiency, then energy and atmosphere, followed by materials and resources, and then indoor environment quality, and then innovation and design, and we're going to have a brief summary on different aspects we talked about and some more information for future reference. So basically, we're going to have this session as a contribution towards your pursuit for the Lead Green Associate Candidate exam, where credentialing also is open now for all of the types of certifications here, credentialings for the lead green associate or the lead accredited professional, and basically it can be taken from home, and you can find the information on the website. But I just wanted to share here some pointers for you. We had this question yesterday, so I thought I'd share this information. So what you need to know about the exam: basically you need to create your profile on the usgbc.org website. It's free accounts. Then you can navigate to the credentials tab, select the exam that you want to take, then just complete the registration process normally, which will then you have the ability to schedule the exam date and time through the Prometric website. So prometric.com/GBCI. The cost of the exam would be for the Lead Green Associate $250, but it will be $200 for USGBC members and $100 for students. The Lead AP Specialty exam is $350. But $250 for USGBC members. There's also an option to go for the combined exam, where the LEED Green Associate and LEED APA specialty will be worth $550, but it can be for $400 for USGBC members. Now, once you do the registrations, the registration itself will be valid for 1 year. So in that year, you are allotted 3 registrations for the exam section itself. But if you don't register, then within 1 year, that will go. So we talked about yesterday briefly about the triple bottom line of sustainability and how it's the gateway and definition to green buildings and specifically the LEED rating system. So it's very important also to take note of this because it will also be part of the exam's question or maybe an objective in the exam that you're going to answer. So the environmental stewardship, economic prosperity, social responsibility. So the question might come is, why do we need to build green? Basically, you can answer this question with simple points. Basically, we need to create more comfortable, healthier, more sustainable built environment, which is basically based on the social responsibility pillar. We need to create these built environments while reducing energy consumption, greenhouse gas emissions, water consumption, and solid waste generation. These are part of the environmental stewardship. And also to reduce the cost, reduce liability, increase value, and achieve more predictable results in design, construction, and operation of the built environment, which is under the economic prosperity. So basically, in short, we build green to transform the way buildings are designed, built, and operated, which comes to the 3 Ps: people, profit, and planet. The built environment has significant effects on the overall environment. For example, in the United States, buildings account for 73% of electricity consumption, 41% of energy use, 38% of all carbon dioxide emissions, 17% of potable water consumption, 40% of raw material use, 30% of waste output. Now, these facts are true from a database from the Environmental Protection Agency as well. And there are many facts that we can share in other platforms for data for GCC countries in Middle East. But basically, the overall underlying point here is that we need to address these issues, and green buildings basically can address them, which include climate change, resource depletion, water consumption, degradation of ecosystem habitats, indoor environment quality, occupant health, comfort, and productivity, and costs of owning and operating. Okay. And we saw this kind of curve yesterday where we saw that the typical building practices are at the highest peak during these times, where the market basically has abundance of typical building practices, and we still have substandard performance buildings. And we hope to shift the market to basically move towards green building leaders, market leaders, and then green building innovators. And we can do that through integrative process. So the concept of integrative design emphasizes basically the connections and communication between professionals and throughout the life of a project. Input from all key stakeholders and members of the design team is essential before schematic design begins. So basically, the earlier we begin with all of the stakeholders with us on day one on the pre-design phase, for example, the better solutions we can have, because the better outcomes will be for different purposes, where we can have and obtain all of the benefits listed in here. For example, it's going to be a learning opportunity for all of the stakeholders when they gather together to learn from each other. It's going to be a reduced environmental impact because our choices would be better based on different parameters. There's going to be an optimized return on investment, potentially no increase in construction cost, especially when it's done earlier in the stages of the building. We're going to have more durable facilities, improved occupant performance, reduced operating and maintenance cost, and also we're going to have better indoor air quality. So those are all of the benefits that we can think of basically in general about integrative approach for green buildings. That brings us to the USGBC mission. Basically the mission for USGBC because it's a nonprofit organization and USGBC is committed to expanding sustainable building practices, and we have more than 16,000 or more organizations across building industry working basically to advance buildings that are environmentally responsible, profitable, and healthy places to live and work. So the mission states here is to transform the way buildings and communities are designed, built, and operated, enabling an environmentally and socially responsible, healthy, and prosperous environment that improves the quality of life. So the key programs under USGBC is we focus on LEED green building rating systems, education and research, chapter programs, outreach, and policy. So in brief, LEED stands for Leadership in Energy and Environmental Design. It's globally recognized, consensus developed. It's a third-party green building certification system, synonymous with environmental performance, economic prosperity, and human well-being. It delivers verified measurable performance in the form of reduced building operating costs, resource consumption, and also water and energy use. It basically cuts building CO2 emissions while encouraging strategies to help create healthier indoor air. Also responsive to new technologies, policy, and built environment changes through an ongoing consensus-based refinement process. The system is based on these goals. So the goals for the LEED assessments is based on the environmental impact, and this is the outcome that there are these LEED goals for LEED V4. So we begin with the global climate change. Basically, we need to reduce it as much as possible, and this is the heaviest one where we're going to see the biggest impacts on LEED based on global climate change, following by enhance individual human health, protect and restore water resources, protect and enhance biodiversity and ecosystem services, promote sustainable and regenerative material cycles, build a green economy, and enhance community quality of life. LEED basically is a tool for greening our homes, schools, and other buildings through market transformation. Comprehensive and flexible, it offers a practical whole building approach relevant to buildings in any stage of their life cycle. A new construction building, the ongoing operation and maintenance of an existing building, and a significant tenant retrofit to part of all commercial buildings are all addressed by LEED certification system. And over here, you can see the 5 main categories of the LEED certification system, starting with the building design and construction, BDNC, then interior design construction, IDNC, EBOM, which is existing building operation and maintenance, homes, and then neighborhood development. So the list is impressive and it may appear complicated, but it makes LEED more appropriate for more projects. And we're discussing the LEED version 4, where the exam will be on. So the exam content, the exam materials are all discussed under LEED V4. Now there's a question that might come is, why does LEED change? And now on the next slide, I'm going to also show you the update of LEED V4.1. Basically, LEED is a continuous improvement cycle that keeps us moving toward not just being less bad, but achieving more good in terms of the environmental impact of our buildings. LEED is basically intended to push the ceiling and pull the floor of building performance to support market transformation. The evolution of LEED balances the abilities of the markets with the urgency of environmental solutions. The latest version of LEED, which is LEED V4, introduced an increase in technical rigor over the current versions, LEED 2.2 of 2009 and prior to that as well. And quite recently, in the past year or so, LEED V4.1 was introduced, and it's basically a simple data-driven performance path for existing building to achieve certification, making it accessible to more projects than any other version of the rating system. And when we talk about V4.1, we talk about performance. So ARC certification, so LEED certification programs are available through ARC. So ARC is a platform where we can access it and measure the building performance through 5 main categories, starting with energy, water, waste, transportation, and human experience. But all of this that I'm talking about, LEED v 4.1, it's not relevant really to the exam when you take the exam, but it's relevant to buildings if any project wants to pursue the newest version of the system, then LEED v 4.1 is here, and more information is available on the website. So in order to be qualified to obtain the LEED certification, there has to be a minimum program requirements achieved. So the first one is that it must be in a permanent location on existing land. Second, MPR, which is must use reasonable LEED boundaries. The third, it must comply with project size requirements. So it's important to note that to earn certification under LEED v4, these MPRs or minimum program requirements are the minimum characteristics that a project must possess to be eligible for LEED certification. Basically, the three goals here serve to give clear guidance to customers, to protect the integrity of the LEED program, and to reduce challenges that occur during the LEED certification process. In terms of the organization of LEED, we talked about this very briefly yesterday. LEED provides opportunities to encourage and recognize performance associated with the following categories, beginning with location, transportation, sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environment quality, and then innovation and design, where we have 10 bonus points in this category. For neighborhood developments, which applies for an entire neighborhood environment, has different categories to address its unique needs, including green infrastructure and buildings, neighborhood pattern design, and location linkages. So for the balance of the course, we will talk about the general LEED categories that underlie all building types, focusing on those 6 categories illustrated over here. So it's important also to get to know the structure of the LEED rating system. So LEED is a system of credit categories, prerequisites, and credits. Each prerequisite and credit has an intent, which identifies the main sustainability goal or benefit. It also has at least one requirement, which specifies the criteria that specify the prerequisite or credit and the number of points available. All prerequisites and all credits must be achieved. Credits are optional, but each one contributes to the overall project score. So for example, if you are targeting to go for silver, then you have to achieve credits that are between 50 and 59 points. And the weights of the credits basically are illustrated in this graph over here, where the majority goes towards energy and atmosphere. And then the other categories fall in line with that weight distribution. And collection of the points gets you the level of certification you target at the very beginning of the certification process. Certification starts at 40 points to 49. Silver is from 50 to 59. Gold is 60 to 79 credits. And then platinum is 80 points and above. GBCI basically manages all building certification, also administers credentialing programs related to green building practices. So USGBC basically handles the development of LEED rating system and offers LEED-based education programs. The LEED Professional Accreditation Program is independently administered under GBCI. This helps to allow for balanced, objective management of the credential. GBCI manages all aspects of LEED Professional Accreditation Program, including exam development, registration, and delivery. GBCI also oversees the development and implementation of a maintenance program for LEED AP credential holders. So why is it important? Because this separation was done to comply with ISO requirements and basically split into 2 separate entities. The organizations that writes the green building standards from the organization who receives payment for the services certifying your LEED building. So it's very important to know what's the difference between USGBC and GBCI, because this also, as a question, comes in the exam. We briefly touched upon this, which is the certification process for commercial and for home projects. So I'm just going to skip through these. So there's different stages for commercial buildings, starting at the early stages of the building to identify partners, register the project in LEED Online, build the project team, apply for incentives, if any, and begin LEED documentation and design process. So the submission for these types of projects can be done in 2 phases. Either it can be done in a combined method where you submit the design and construction documents together, or it can be done on a split review basis where you submit the design, have the review done, and then follow up with the construction, submit it, and get the review for the construction. Following that, the final stage is the certification phase. For homes, it's a little bit different, where in homes, you have third-party verification bodies along with the project team. So there's had to be a lead for home provider, and then follow up with the normal process of registering the project on USGBC, build a project team, identify incentives. In the project, once the construction is going on, the project team manages the construction process, but the green rater completes all project verification. So in addition to the home provider, there has to be a green rater. So the green rater finally prepares the submittal package, provides reviews, submittal package. USGBC then reviews and certifies the project, and then there's had to be a training and handoff to the occupants. So that's in summary the basic difference between the process for commercial buildings and for homes. And all of the references are available. So the reference guides for building design construction is shown here. And there are multiple building volumes online for different rating systems, including O&M, operation maintenance, interior design, neighborhood development, and homes. Also, checklists are available for people to use to guide them in the credits they want to achieve and see if they can really achieve it or not throughout the whole project. In addition to that, the lead online is available as a tool to register and document the project through to certification. Many project teams basically utilize this tool for planning and tracking purposes, not solely just for project documentation. This is an example of the credit forms available also online. This is for the sustainable site credit and rainwater management. So LEED is basically global, and it introduces something we call alternative compliance paths. It basically is developed to address unique needs and projects outside of the US. So the global ACPs, or alternative compliance pathways, offer additional approaches to credits traditionally more difficult for projects outside of the US to achieve, and are a first step toward providing globally consistent solutions. So in addition to that, the credits, we're going to see throughout this presentation how the synergies between each of these credits can be achieved. So the big idea behind it is really to achieve the integrative design process that we discussed in the beginning. And it's actually basic credits that can be achieved, and it's new in LEED v4 and falls outside of the traditional credit category. It basically does not have a credit category, as it's a preliminary step that affects all credits. This credit is about structuring the design process to address building system design in a comprehensive and multidisciplinary manner. And it basically identifies use opportunities to achieve synergies across disciplines and building systems. So that's basically the introduction, and we're going to go through all of the categories following this. This is a sample question that can come in the exam. So this question shows different options. The questions that come in the exam are similar to this. All of the exam is a multiple choice question. So a question says, what constitutes the largest use of energy in buildings in the United States? So just to move on, the correct answer is B, space heating. So basically, according to the US Department of Energy, 30% of all energy used within a building is used for space heating. Lighting is basically the second. Okay. Second question, green building emphasizes using what type of design process? So the answer is C. This is one of the most typical questions that comes in the exam. The green building emphasizes on integrative process. Okay, so let's begin with the detailed credit categories and the detailed description of them. So we'll begin with the location and transportation. So let's think about it, and we're going to look at different perspectives and aspects under this category. So the concepts here is we want to achieve a compact development. And we can do that through, for example, using alternative transportation, connection with amenities, using existing infrastructure, walking and bicycling distance, calculations based on the distance, parking capacity, and preferred parking. So in terms of the different phases of the building, the concept of integrated design emphasizes the connection between and communication between professionals through the life of the project, as we said. And it recognizes the projects that pursue an integrated approach to the design, construction, and operation of sustainable sites. So basically, we're going to see this in all of the categories, and we're going to look at how the integrative approach is going to be achieved through this category, this and other categories, and then the synergies between the categories as well. So for the location and planning, these are the points that are underlined in the in this category. So first, choose a smart location. Second, avoid and protect natural areas. Encourage density and diversity, and create accessibility. So as an example, it's very important to locate the building within current infrastructure. So what we need to do is when we think of the location, if we have the choice to basically choose a location, we choose it based on the access to transportation, for example, employment, housing and services, basically this that makes advantage for existing infrastructure. And the goals here are basically to limit the expansion of the growth outside of the city and to choose something that's within the current infrastructure. So this is an example showed that we provide access to multiple transportation modes, for example, within a quarter of a mile of bus stop or within half a mile from a light rail station. Encourage car sharing or van pools. So instead of single car use, we encourage car sharing and van pools. Plan for bicycle accessibility and reduce number of parking spaces. Now, location and transportation points are awarded for providing alternative transportation options for occupants and by demonstrating the occupants use alternative transportation. So we want to encourage people to really use different transportation modes rather than just the single car use. Okay, now you're going to see this table quite often in these categories in this presentation, but I'm going to skip through them. Basically, we have the definition here for the types of buildings. NC means new construction. Schools, CS is core and shell. CI is commercial interior. EBOM is existing building operation maintenance. Homes, and then neighborhood development. Now, the list of the credits are detailed in the reference guide, and it's available in the credit library on uscbc.org website. One of the key things that we need to do when we select the location of the site is basically to avoid impact on sensitive habitats, built on previously used sites to avoid disrupting virgin property, protect buffers, avoid floodplains, and avoid slope steeps. Buffers basically is protecting areas around sensitive habitats, limit disturbance such as noise, light, runoff, and trampling. It also is critical to protect water quality by ensuring a natural buffer to filter runoff. Floodplains, it's very simple. It's avoiding the floodplains. It's a natural if under a predictable process, but by avoiding new development in floodplains, sustainable sites basically can reduce the risk to people and property. Steep slopes, it's very important, and it can be difficult and expensive to develop. So they also can be a significant source of soil erosion. So sustainable sites avoid and protect these areas to reduce environmental impacts. Okay. It's important also to locate the sites near services. So building in a location that has access, as we said, to employment, to housing, to other services, basically this will decrease transportation demand and increase connectivity. It's important to locate new transportation. So sites that have access to many different types of transportation reduce dependency on motor vehicles and reduce transportation-related social, economic, and environmental impacts. And it's also ensuring access to infrastructure. So site close to existing infrastructure reduce the economic and environmental cost of new development. In addition to that, the housing types also need to be considered to be in a diverse selections for people to actually have the privilege of selecting different housing types to meet their own needs. The selection of the sites, the best case scenario is to basically select a previously developed site. So this is one of the strategies. Basically, we call it the brownfield site, and we restore the sites that used to be used for example, industrial services for manufacturing, for example, or car servicing or whatever. But the purpose of that site was contaminated by chemicals, for example. So the best case scenario here is to reuse this site, clean it, get rid of all of the chemicals. So you're adding benefit to the environment by cleaning the site from its contaminants. And also you're benefiting economically because you're not gonna have extra costs to build a new site with new infrastructure, new material. You're basically reducing your overall cost, improving the environment, and saving all the resources that we have. So this is one of the best case scenario solutions to go for, is to restore a site. In addition to that, the choice for the location transportation, we try to encourage density and diversity, as we said. When we create a compact development, that's what the issue I'm saying is, try not to go in a horizontal way, try to build up, not out. So that's even on a city scale or neighborhood development. It's trying to go vertical instead of going horizontal. So we're trying to reduce our urban sprawl. In addition to that, we want to provide proximity to diverse services and provide diversity of housing types. So the housing types, for example, can include range of housing accessible to desirable for people at different life stages, for example, different income stages that can basically contribute directly to the sustainability of the neighborhood and the communities. Traditional sprawl can be reduced by selecting a site around by existing development and infrastructure. Sites often are described as mixed-use infill developments. Compact developments such as relatively dense projects with relatively small geographic footprints locate projects so that it is possible to walk to diverse services such as banks, your grocery stores, post offices, your restaurants, daycare, and many more, and even mosques. So think of diversity with these infill projects. Basically, you're going to have all of your services within walking distances. So it's very important when we also think of the compact development and the services close by, it's to ensure walkability. So accessibility combines multiple strategies to make it possible to reach multiple destinations through a variety of transportation options. So our sustainable projects use a variety of strategies to increase connectivity both regionally and locally. This includes connections between jobs and homes, employments and services, also the built and natural environment. So again, when we think of walkability, we also need to make sure that walkability means safe and comfortable as well. So walkability in a hot area, for example, like in Dubai, Abu Dhabi, Riyadh, is very different than considering it for a mountain region. So walkability here is very important. Design dense street grids. One of the most important strategies to ensure accessibility is safe and connected sidewalks. This includes creating functional connections between destinations, along with adequate lighting and signage. So it's very important to have it safe and connected sidewalks, link residents and places of employment with destinations. And finally, provide access to recreational spaces. So people thrive when they are connected to nature. Sustainable projects basically need to provide safe and connected connections between work and home, and both passive and active recreational areas. Okay, so these are the goals and the credits for this category for the reuse and restore building sites. I'm gonna move on. We discussed basically the selection of a site, where we call it the brownfield site, and restoration of a site. And the synergies between this category basically and other categories, we're going to see it as basically a site location can reduce use of an automobile. And then the next category, when we talk about sustainable sites, we're going to see that effect directly. Site location can provide building orientation options. Also, we're going to see that in the next category. Density and diverse uses reduce buildings' environmental footprint. So basically, the location transportation credit provides a foundation for other green building strategies. The site selection can reduce transportation impact, which often accounts for 30% of building operating carbon footprint. So let's review this module for the location and transportation category. Again, in each category, I'm going to give you some examples for questions from the credentialing exam. Select 4 types of transportation that LEED encourages through credit points. Again, if the question comes in the exam, it will tell you briefly and clearly how many choices you need to choose. So the question here says, select 4 types of transportation that LEED encourages through credit points. If you think of the question from another side, basically you can say, select the only one that LEED does not encourage. So to move on, okay, so it's quite obvious when we say the encouragement here. So discouraging single person use automobile. Another question, which 3 types of site locations should be avoided when selecting a site for a LEED certified building? So the answer, the question here is to select 3 types. So the question itself is a bit kind of tricky, so you need to understand the question. So the 3 types of site location that should be avoided are basically A, C, and D: wetlands, farmlands, and parks. Brownfields are actually the only one here where LEED encourages us to select. Okay, so I'll keep moving on. We're going to take the sustainable sites, and then I'm going to stop if you have any questions. So the sustainable sites category is very linked and close to each other with location transportation. And you're going to see that in terms of the integrative approach and how it's going to be in synergy with other categories. So what the intents of the sustainable site category is basically to analyze relationships between site and proposed facility, restore the project site to its natural elements, preserve biodiversity, and integrate the site with local and regional ecosystems. So again, with the integrative approach, basically we want to achieve the link of communication between professionals through existing life cycle projects. So LEED encourages and recognizes projects that pursue an integrated approach to the design, construction, operation of sustainable sites. In terms of the design aspect over here, we're going to locate, plan, and design to reduce the impact of the increased sustainability by reducing transportation demand. So you can see here the link directly with the previous category. If we design the site in accordance with sustainability measures, linking it to other infrastructure available, minimizing stormwater impacts, for example, protecting habitat, reusing or restoring the sites, all of this can be done through the design process. Then when we go for the construction, during the construction process, it's important to build as designed and minimize impact of construction to protect natural habitats such as surface water, aquatic ecosystems. Then finally, during operations, it's important to sustain and improve performance over time. So as we said in the construction, to build as designed, in operation, we need to exceed the performance that we set in the very beginning. So limiting use of potentially harmful chemicals throughout through site and building maintenance, and to maintain on-site habitat and stormwater management systems. So we're going to look at different strategies over here. So strategies to choose a sustainable site. Basically, we need to conduct a site assessment. This basically is an investigation of special features of the site, such as terrain, possible contaminants, location of vegetation and wildlife, to center the design around it. So that's for the conduction of a site assessment. The second is plan for open spaces. So if possible, plan for open spaces that feature restored habitat areas and places for people to connect to nature. So we want to also think of reusing or restoring habitat if it's available. And this shows the different credits for different building types. Again, this is available on the reference guide and also on the credit library in the website. So for the sustainable sites, we're going to look at the different concepts over here. The first concept is to analyze the relationship between the proposed sites and the facility design, and how it can take advantage of existing infrastructure. The second concept is to restore the project to its natural elements. So with this site design and management, we're going to look at the site assessment, how we can use the open spaces and how it's impacting this category and others, protect surface waters and aquatic ecosystems, reduce heat island, reduce light pollution, protect human health, and reduce environmental impact. Okay, so natural areas can be protected by limiting project development, footprint, and maintaining open spaces, natural areas, preserving natural habitats, and providing buffers around sensitive areas that expands beyond where the building is located to include how the site is treated. So for example, the first one is when we think of strategies to preserve habitats and wetlands, is to use native and adapted plants. And it's very important to do this. So basically, we want to restore the site that provides valuable habitat while often reducing maintenance and irrigation costs. So it's two things. Either we use native plants from the region or adapted plants that can be adaptable to the climate conditions and the environment. We need to completely refuse using invasive plants. So invasive plants are a big no-no, that we don't need to use them because they're going to be invasive to the environment and they're going to need lots of maintenance and lots of irrigation. Okay, the second point, to protect the majority of the site. So we need to limit the project's development footprint and maintain open spaces than natural areas. So that's within our site. We try to limit the footprint of the building and try to incorporate open spaces as much as possible. The final one in these strategies is to limit site disturbance. For example, prevent soil compaction and resulting in erosion. LEED requires projects to limit the extent of areas impacted during the construction process. For example, this is an example of erosion and sedimentation control. So we want to limit the site disturbance, provide for erosion and sedimentation control. For example, we can use silt fencing. We can create setbacks around the construction areas to protect the areas from heavy equipment and tampering by people. This definitely will reduce stormwater runoff by increasing soil infiltration areas. So this is a natural kind of way to make sure we control the sedimentation and erosion during construction. Okay, so strategies to protect surface waters and ecosystem. Basically over here, we want to, for rainwater, stormwater, basically they can be reduced by limiting impervious surfaces that don't allow water to soak into the ground. So, and by collecting and sometimes reusing stormwater. So we want to think of managing rainwater as much as possible. And we can do that by using best management practices. So we can treat stormwater runoff to move excess nutrients and suspended materials such as eroded soil. Examples for best management practices include vegetated swales, buffer strips, detention ponds. All of these slow and filter stormwater runoff. So eventually we want to reduce the runoff as much as possible. So planning for erosion and sedimentation control during construction is basically very important to protect local waterways from development-related pollution. So examples, limit impervious surfaces areas by introducing landscape or pervious paving, such as the one in the picture here. Intercept and manage stormwater by covering exposed soil, trapping sediment close to its source, slowing or trapping sediment in moving water. This also shows one of the examples of best management practices for rainwater stormwater management. And we want to do this basically to eliminate pollutants that affect the groundwater and nearby water bodies, thereby contributing to a healthier watershed. So the sustainable sites are designed to direct stormwater flows into vegetation, dry ponds, rain gardens, bioswales, and etc. And there are many other numerous best management practices that we can share. In terms of outdoor filtration systems, this is an example at a middle school. This example, basically, smart water management is central to the project design for this school. A constructed wetland between the new and old wings of this school treats wastewater from the kitchen and bathroom and serves as living laboratory where students can learn about biology, ecology, and chemistry. So this is one of the benefits of using an existing condition of the site for education purposes. So this is for a school project where they use this biofilter to actually do examples for it in biology, ecology, and chemistry classes. Okay. In terms of rainwater management credits, it basically includes two metrics. The first one is precipitation volume metric. Now we measure this by percentage of stormwater event retained on site. The second metric is water quality metric. So we measure this by percentage of removal of nutrients and suspended soils. So those are two metrics that are very important to keep in mind on how we measure the value of rainwater management. One is by volume, this other is by quality. Okay, moving on to several strategies here to reduce heat island effect. So it's very important to reduce heat island, and we discussed this briefly yesterday in session, where heat island effect is basically the ability of structures to preserve heat gain through daytime and then releasing it back to the night during nighttime. So what we can do to reduce this impact or reduce this effect is reduce heating from rooftops, reduce heating from hardscapes. And we can also do that through different strategies for surfaces such as reflective paving surfaces. So selecting light color reflective paving materials can also reduce heat gain. And it's important also to consider the SRI, to have it in a high range where the solar reflectance index is basically something that green buildings encourage to use high values of SRI to reduce the heat throughout the day. And it's measured as of a constructed surface ability to reflect the solar heat. So that's one thing that we can do for surfaces in the exterior spaces. And this is an example of the credits compared to different building types. So the credit is heat island reduction. Now, for strategies to reduce light pollution, we need to control exterior lighting. Light pollution basically is both environmental and quality of life issues. This strategy involves designing the site with appropriate illumination levels so that it's lit effectively without being overlit. So we need to control exterior lighting, and it can be designed basically to minimize waste light that can negatively impact nocturnal animals while still maintaining safety and comfort. In addition to that, it would be much, much more effective in terms of economical value to really focus the lighting on the tasks that we need instead of just having it abundant and lighting everywhere where we don't need them. Okay, strategies to reduce maintenance impact. We have a concept here that's a low impact maintenance. Basically, we need to reduce the introduction of and potential exposure to toxic chemicals. So low maintenance, so low impact maintenance, we need to plan and implement building management practices that minimizes environmental impact. Examples for this, basically we use equipment that minimizes noise and emissions. We can use clean exterior using environmentally friendly methods. We can reduce the amount of yard waste delivered to landfill by mulching, control fertilizers use, and water consumption. So in terms of synergies, we can see that the sustainable site category provides the foundation of other green building strategies, particularly those related to LEEDs, energy and atmosphere credit category. So by design, if we design the site to be sustainable and think of the orientation of the building, benefit from other exterior aspects such as adjacent buildings or the wind direction, solar direction, all of those effects in this category can have a big advantage when we talk about the energy and atmosphere credit. So site design helps orient buildings to enable them to capture useful solar energy, for example, while avoiding unwanted heat buildup. Reflective surfaces and shading also help increase occupant comfort while reducing heating and cooling loads, ultimately reducing energy use and greenhouse gas emissions. So these are kind of the idea behind the synergy between this category and other points in other categories. We use the ASHRAE ISNA 90.1 for exterior lighting standards that set basic requirements for commercial buildings, including the use of controls like photo cells and timers. There exists a variety of exceptions for safety and special use area. And finally, it's important also to think of financial incentives and government programs that encourage the reuse of infill and brownfield sites. So if a sustainable site is selected, incentives can also be included, expedited permitting, density bonuses, for example, which allow for bigger, denser development, additional promoting water quality protection through a combination of smart growth and low impact development is often eligible for incentives. So that was kind of like a deep dive into the sustainable site category. Let's review with a couple of questions that are similar to ones in the exam. So the question says, a project that specifies exterior surfaces with high solar reflectance index, high SRI values, is contributing to which environmental benefits? Okay, I see some answers correct. Okay, the answer is A. So when we have high SRI value surfaces, basically we are reducing the heat island effect. So if you remember the slide with the shading from black to white of the high SRI value, so the higher the SRI value of the surface, the better it will be reflecting the sunlight and reflecting back the heat. So we will basically reduce the heat island effect. Okay, another question. Decreasing impervious surfaces on a project site will what? So basically, to answer this question, you need to understand what is an impervious surface. Okay, to move on, the correct answer is C, reduce rainwater runoff. So an impervious surface means a surface that cannot absorb water and take it into the underground water body. So an impervious surface basically decreases the runoff water from basically going into the ground and being absorbed. So we, in LEED, we encourage the use of pervious surfaces, such as the example I showed you where we have the landscape using gravel and open pavement. Okay, so do we have any important questions, Deepti, or should we continue?
We don't have any questions so far, so I think we can go ahead.
Okay, great. Okay, so moving on to the water efficiency credit category. So think about it. We talked about several issues in the sustainable site category related to water. So in addition to what we talked about in the water efficiency category, we're going to talk about these three main things: indoor water use, cooling tower water use, metering, and monitoring. So indoor also is associated with outdoor water use. And when we talk about the water efficiency category, basically, we talk about it in the integrated process approach. So in terms of design, during the design phase, the integrative approach prefers to reduce the demand through efficient fixtures, for example. Appliances and systems provide the capability to capture and reuse water on site and reduces demand on public water infrastructure. So we need to design that can provide the foundation for using most appropriate water for each purpose. And then during the construction, the integrated approach supports the project being built as designed, including use of specified fixtures and systems. Then finally, during operation, integrated approach supports fixtures and systems being maintained and used as intended. As part of this approach, it's important to also monitor and improve performance of system over time. So we're going to look at the water efficiency from an overview of these three perspectives in terms of processed water, indoor regulated water, and outdoor water. So indoor regulated water reduces the amount of water required to accomplish indoor water uses. Processed water efficiency reduces the amount of water needed to satisfy building processes. So the amount and type of processed water will depend greatly on the building systems and functions. And then what outdoor water efficiency reduces the amount of water needed to meet the irrigation needs. So we'll look first at the indoor regulated water. So two things here stand out we need to apply is to reduce potable water demand and increase water use efficiency. So it's very important, and according to the U.S. Environmental Protection Agency, older efficient toilets are responsible for most of the water wasted in American homes. And we can see also the same thing here happening with indoor fixtures. So it's very important to reduce indoor water use, and it can be achieved by installing equipment that uses water more efficiently. Nowadays, we can see these regulations and items in the current building codes that regulate the use of high efficient fixtures. The flow rate of it is efficient. And for example, commercial buildings have reduced water by utilizing captured rainwater and non-potable water sources for toilet flushing, among other functions. High efficiency fixtures are another critical approach to conserve water. So some strategies to basically reduce potable water demand indoors. One of them is to use non-potable water where possible and allowed by code. This is one of the most important things is do not apply something that is not approved by code. Any category that is underlined in the LEED system needs to be in accordance with local regulations and international codes as well. So to effectively reduce water demand, you must understand how much water is being used. So this is best done by metering water use, indoors and outdoors. It's important to know this through installing monitoring sub-meters. Why is it important? Because the facility team can better understand where water is being used in and around the building, and therefore on what systems it should focus on reducing water use. So in addition to that, use water efficient plumbing fixtures and appliances. And as I said, nowadays, it's very abundant in the market to use these fixtures that have low flow rates, high efficient fixtures that can be dual flush systems, for example, even waterless fixtures. Another example for effective and efficient water reduction is gray water captured rain. So gray water, what's the definition of it? is basically untreated household wastewater, which has not come into contact with toilet waste. So gray water source include wastewater from sinks and showers. Basically, you can reduce water demand by capturing rainwater and other non-potable water sources and reusing them for toilet flushing, among other internal functions. This is an example of rainwater catcher barrel, which was designed and used outside of the house to capture rainwater and use it for irrigation. Another example is black water. Black water does not have a single definition accepted nationwide. So wastewater from toilet and urinals is always considered black water. Wastewater from kitchen sinks, showers, bathtubs, all of these may consider as black water by state or local codes. So it's very important to go back to your local code and regulations from the building code and see what black water is defined. What functions come out of it, black water. So it's important to go back to the local codes, see what is gray water, what is black water. Many strategies here we're going to discuss in water efficiency indoors and outdoors to increase water efficiency. One of them is to use high efficiency or waterless fixtures and appliances. So for example, when we use fixtures in toilets, we can use ultra low flow urinals. We can use low flow toilets or dual flush systems. Faucets with aerators, for example, or high performance low flow showers can operate at less than 1.5 gallons per minute. So it's very important here in terms of metrics. We talked about the metrics in the sustainable sites. Over here, when we talk about the metrics, we talk about the maximum flow rate. So this table shows the flush fixture, and it shows the flush rate in the terminology of gallons per flush. So what is the baseline here is the first one, conventional water closet, which the flow rate of it is 1.6 gallons per flush. So we need to achieve any of these. So any of these that have low flow rates are considered to be efficient in terms of water consumption, water use. In addition to this, there are fixtures over here that use the flow rate of gallons per minute. So for example, we have conventional private lavatories use 2.2 gallons per minute. We have conventional public lavatories. So it's very important to look at these and look at the concept of full-time equivalents and also gender-neutral fixtures, for example. So many issues come into play here when we do the calculations for this credit. But the prerequisite here is basically to have the reduction of water consumption as much as possible. So some rating systems will have more prerequisites or credits associated with a goal. So for example, new construction, schools, core and shell have both the water efficiency prerequisite 1 and water efficiency credit number 3, which is basically the water use reduction. Okay, moving on. So that was basically for the indoor regulated water. Now we're going to look at the outdoor water use. So according to the U.S. Environmental Protection Agency, landscape irrigation in the United States is estimated to account for almost 1/3 of all residential water use, totaling more than 7 billion gallons per day. Typically, the largest consumer of commercial outdoor use is from site irrigation. The goals here under this credit is basically to reduce potable water demand and increase water use efficiency. Strategies that can be done here in outdoors, basically when we think of the irrigation that we're going to use outdoors, is first of all to reduce irrigation water use that can be achieved by installing equipment that uses water more efficiently. As with indoor water use, outdoor water use can be metered to be better understood how much water is being used. We can even use drought-tolerant, adaptive, and or native plants. And also, capturing gray water or gray water for irrigation is a big bonus and a big plus over here. The gray water that we talked about and the black water has to comply with the local codes and regulations in your country, in your region. And using those codes can tell you if you can use that for irrigation or not. In addition to the selection of the landscape, the type of fixtures you're going to use for irrigation is very important. So it's very important to use high efficiency irrigation technologies, such as drip irrigation. You can use smart technology to sense the landscape when it needs water, sense the environment when you need to irrigate the landscape, and so on. In addition to the fixtures and to the equipment using for irrigation, we need to also monitor the water use to make sure that we don't have any leakage, we don't have any issues, and that the design and construction of the irrigation system keeps on the life cycle of efficiency throughout the life cycle of the building. So that's basically what we need to focus on when we talk about outdoor. Now, finally, in this credit, we're going to talk about the processed water. And over here, we're talking about the water that's used for industrial processes and building systems, such as cooling towers, boilers, chillers, dishwashers, and other appliances. Water used in building cooling often accounts for 40% of buildings' water consumption. So the goals here is to reduce potable water demand and increase water use efficiency. The first thing in the strategies to reduce potable water demand for processed water is to substitute with non-potable water, because we don't need potable water for cooling towers over here. As both with indoor and outdoor water use, we need to reduce utilizing captured rainwater and non-potable water sources or gray water in cooling towers, chillers, and boilers. And replace evaporative losses with non-potable, make-up water, for example. Non-potable water can be harvested from rainwater, air conditioning condensate, or municipal reclaimed water. But again, it's very important to go back and check with your local codes and building codes. Strategies over here also is to include sub-meter for cooling towers. It's also because since the processed water volumes can be significant, an effective way to understand how that water is being used is to install sub-meters on each of the key water using system. So sub-metering a cooling tower provides the basis of tracking and trending water use over time. In some places, it may also provide the basis of incentives from water or sewer companies or credits, since processed water not entering the sewer system. And in addition to that, improving cooling tower chemical management can heavily reduce or eliminate even potentially toxic water treatment chemicals. And we need to balance the chemicals here used because of the environmental impact. Okay. In addition to the chemicals and the water efficiencies for cooling towers, we need to have water conservation, which saves electricity and reduces greenhouse gas emissions. So that's kind of like the basic advantage when we think of the synergies between water efficiency and other credits. When you have high efficient water fixtures, indoors, outdoors, or even for the water process cooling towers and so on, it's closely linked with energy. So, for example, we need energy to heat water. Potable water running out of the tap is associated with significant amount of embodied energy. So pumps are working on electricity to give us the potable waters indoors. So typically electricity is used to extract, convey, and treat this water. Basically, water conservation actually saves electricity, reduces the greenhouse gas emissions. So water efficiency and site design are closely linked with also native and adaptive planting, which reduces water demand. So LEED evaluates indoor water efficiency with respect to performance benchmarks using standardized references measures for water efficiency, such as the Energy Policy Act of 2005, 2006 Uniform Plumbing Code, 2006 International Plumbing Code for fixtures and fitting performance requirements. For the calculations, the water use in the following devices is now included in LEED V4 water calculations. These include residential commercial clothes washers, residential dishwashers, pre-rinse spray valves, ice machines, heat rejection and cooling devices, and cooling towers and evaporative condensers. Similar to the previous categories, it's very important to think of incentives, recognition, and regulations for water efficiencies. These incentives can be local or international. It's important to think of these, and these can be also tackled in the very early beginning stages of the design, where we talked about the integrated approach. Basically, we can think of these financial incentives, recognition programs, and also to set the goals and requirements to achieve the code. So that's basically a detailed overview of what is included in the water efficiency. So we talked about three things: indoor water use efficiency, outdoor water use efficiency, and process water. So the question also here is similar to the exam. So the question says, what is reduced when a project uses reclaimed water in its cooling towers? Okay, I see lots of answers, but no correct ones. So again, focus on the question. It says, what is reduced when a project uses reclaimed water in its cooling towers? So it's important to know what's the meaning of reclaimed water. So what we're reducing is basically we're reducing the use of potable water use. So the answer is A. So when we use reclaimed water in our cooling towers, we are reducing the demand on potable water use. And we are leaving the use of potable water for purposes that accompany and use for potable water use, such as drinking, showering, and so on. Okay, another question. Non-potable water is typically suitable for which of the following uses? Select two. Again, this is also similar to the exam procedure. It will tell you how many choices you can select. So, non-potable water is typically suitable for, I see some correct answers, yes, D and E, toilet flushing and irrigation. None of the above three, A, B, and C, none of them have, we cannot use non-potable water with them. The only choices here we can use non-potable water is for toilet flushing and irrigation. So I hope that's clear for the water efficiency credits. Now I'm going to move to the energy and atmosphere. So moving on to the energy and atmosphere credit, which is the highest credits achieved under the LEED rating system. And the key concepts in this model, basically, we want to think of optimizing energy efficiency. So similar to the water efficiency category, we want to also here have high efficiency in terms of energy saving in different aspects such as lighting, heating and cooling, refrigerant management. We talked yesterday about the concept of commissioning. We're going to talk about it in detail here. So when we think of buildings, and I showed you the figures in the very beginning of this presentation, yesterday's presentation, where buildings consume about 38%, almost 40% of the energy in a total, where 72% of electricity consumed is basically for HVAC systems. Energy consumption can be dramatically reduced through economical and readily achievable practices. So what we want to achieve, what are the intents of this category, is to reduce the energy use in different aspects. In addition to that, we want to increase energy efficiency and meet energy needs with clean, renewable, and energy supplies. Now, when we think of this also in the integrative approach, so the first thing we think of it in the design process is the location. We talked about this in the location transportation credits and the sustainable sites category. So location of the site, plan and design to reduce impact and increase sustainability by reducing transportation demand. Will also minimizing stormwater impacts, protecting habitat and reusing or restoring the site. During construction process, it's important to build as designed and minimize the impact of construction to protect natural habitat, surface water, and aquatic system. In terms of operation, sustain and improve performance over time, limiting use of potentially harmful chemicals through the site and building maintenance to maintain on-site habitats, and so on. So it's obvious that the integrated approach can be done here in many aspects through design, construction, operation. So what we're going to talk about and the LEED goals related to this concept are basically these 4 items: energy demand, which is the absolute amount of energy needed for a project to fulfill its requirements. The second is energy efficiency, which is the measure of the amount of productive work accomplished per unit of energy expended. The third is energy supply. This refers to the source of energy used to meet energy demand, such as natural gas and electricity. Finally, the energy performance is the actual measured use of energy during operation, the most meaningful measure of project performance. So we will look at the goals and strategies of each energy demand. So we look at the energy demand first, and we want to basically over here reduce energy demand. So low energy buildings design is not just the result of applying one or more isolated technologies. It's an integrated whole building process that requires advocacy and action on the part of design team throughout the entire project development. So the ultimate goal of reducing energy demand include reduced negative impact on the environment, in addition to meeting energy needs and cost effective. These are some of the metrics that we use for different energy typical uses for building types. This is something that as an example, but it's not something that you need to worry about here. This is just for your information, okay? Okay, so the concepts over here that we're going to use to reduce the energy demand, the strategies you can see here, some of them are basically related to design, some of them are construction and operation maintenance. So when we talk about shading, for example, this can be heavily impacted when we talked about it in the sustainable sites and location. Shadings, for example, that we can benefit from adjacent buildings or local habitats such as trees. Here we have different types of trees we can use also to benefit us for shading. The site design orientation, site design itself can also help us in designing in a passive way where we use the sun orientation, the wind and ventilation in our benefits. So in addition to that, the building design and mass itself can help us in reducing the thermal mass of the building. So it's basically the ability. Excuse me. Yes, okay. Daylighting, also using of daylighting can heavily impact the energy efficiency. So using of daylight can also help us create a healthy indoor environment. Natural ventilation is also a bonus, where in some climates it's an advantage to use natural ventilation, but in some climates it's impossible. So we need to consider that in the natural ventilation point. One of the other points is also to reduce building size. So one way to reduce energy demand is to appropriately scale the building to fulfill the facility's functions. So we don't need spaces that we're not going to use. And this is a case that we actually have here in our region, where we have large spaces for guests where we're not using them quite frequently. And sometimes it reaches 40, 50, or even 60% of the total area of the space is basically dedicated for guests. And they use it twice, 3 times, 4 times a year. So it's important to reduce building size to the functions that we actually need, nothing more. These show us the credits allocation under the reduced energy demand. So it's a prerequisite to have a minimum energy performance. And then different allocation credits can be allocated here to get higher ranks in the levels of certification. Examples of best management practices is one of the examples here is building orientation. So just one aspect of design can have great impact on the operation and maintenance of the building. So this will reduce demand for artificial heating, cooling, ventilation, and lighting. Another example is the ventilation. So again, selecting the appropriate location of windows, openings in the building can also have great impact on the energy demand. So using natural ventilation can help us also improve the indoor air quality, where we're going to see this in the following section. After the material section, where we're going to talk about the indoor environment quality. Other technologies or techniques we can use, for example, passive cooling. So this is an example of using air that travels through these pipes, and it can be cooled down or heated depending on the conditions of the climate, and it can help us reduce the energy demand to heat or cool the air that's going to go into the building. So instead of heating or cooling the air at 100% capacity, this technique for passive cooling can maybe reduce it to 20%, 30%, 40%, and so on. So eventually, we're going to reduce the energy demand to heat or cool air that we need to use indoors. Again, one of the examples is to use passive solar. So this diagram shows the indirect gain of heating system, showing a collection of solar energy in the south-facing facade. This is a good example for cold climate areas where we need to actually collect heat. It's vice versa in our region over here where we want to reflect heat. So it's important to think of this in respect of energy demand as well. So that's in terms of the energy demand. Now we're going to talk about energy efficiency. And in this point, we talk about the energy efficiency that recognizes energy baselines, also to identify opportunities for efficiencies. So strategies here recognize the energy baseline. Basically, we want to achieve whole building energy simulation at the very beginning stages of the design. And that energy simulation can help us make the decisions on how to change the orientation of the building to minimize the energy demand. And it's also important in the very beginning stages to establish reference baselines. So, for example, consider typical energy use patterns for different building types, compares to statistical databases, perspective versus performance-based approaches, compared to code-based energy models, and so on. So it's also important when we do the whole building energy simulation, this will enable the project team to establish an energy performance baseline by using the model that meets the energy, the minimum requirements of the energy code or standards, such as ASHRAE 90.1. It also identifies and prioritizes energy conservation opportunities by evaluating trade-offs between capital and operating costs. So the module building is built in a computer program per requirements of ASHRAE 90.1. So strategies to identify opportunities for energy efficiency over here, we talk about water heating, computers and appliances, equipment, lighting, building envelope. So in water heating, for example, it can be a major source for energy demand and an opportunity for energy efficiency using high performance systems. For example, in water heating, we can use high efficiency condensing boilers, which significantly basically increases thermal efficiency in comparison to conventional boilers. We can use solar thermal water heating systems on rooftops, for example, solar panels to heat water. For computers and appliances, we can use, for example, laptops instead of desktops, which can increase energy efficiency while still performing many of the same tasks. We can select equipment that has an Energy Star rated appliance Equipment, for example, for high performance building systems such as heating, ventilation, air conditioning. We can use the variable air volume ventilation system, which saves energy by reducing the amount of air that must be conditioned and moved. Energy recovery systems, demand control ventilation systems increase efficiency by matching the HVAC system. Lighting nowadays, we have the LED lighting, which is very efficient. And also it's important to consider the building envelope, which is a big contributor when it's sealed correctly with no possible leakage. That will save us a lot in terms of cooling or heating the space. One of the strategies we talked about also is the thermal heating system, which uses solar panels. Of course, the advantages and disadvantages, we have to consider them here based on the technologies we have in the market. In terms of lighting, we need to also select high performance lamps. LED lighting, for example, replaced fluorescent lighting in many applications due to its energy efficiency and long service life. It's also important to think of the refrigerants in the HVAC system because this uses lots of energy to cool down air. So the refrigerant chemicals itself are classified based on two things. One of them is called the ODP, or ozone depleting potential. The second is the global warming potential. So we need to classify the refrigerants based on these two categories. The chemical name or the scientific name for them, the first one is CFC, or chlorofluorocarbons. This has been banned by the Montreal Protocol, so we no longer use CFC. We still use HCFC, but again, it will be banned by the Montreal Protocol due to its high potential in global warming. The CFC was very bad in terms of ozone depletion potential. So the problems we had with the ozone basically was contributed by the CFC chemicals. So now we, through different strategies and different systems and different regulations, we need to use refrigerants that basically reduce our ozone depletion potential and global warming potential. Okay, so we're going to move to the energy supply, where it's important when we think of the power generation is to think of renewable sources as much as possible, and which avoids basically air and water pollution and other environmental impacts associated with production and consumption of traditional fuels such as coal, nuclear, oil, natural gas. So renewable energy can be less expensive in some areas of the country depending on the natural elements present. Utility and public benefits fund rebates may be available to reduce the initial cost of purchasing and installing renewable energy equipments. So we want to use incident energy and purchase off-site renewable energy, and we're going to see these strategies in detail. So the first is to use renewable sources, and the best solution is to use them on site. And the sources we can use are considered to be, for example, photovoltaic, solar thermal, wind, biofuel, low impact hydroelectricity, wave, and geothermal energy. So these examples are very good in terms of energy efficiency and harvesting renewable energy, reducing my loads on the infrastructure or the utility bills, and also benefit us in terms of the environmental impact. So that's when we talk about harvesting site energy. Okay, just a schematic diagram showing the advantages of on-site conditions. Some conditions where we don't have the ability to source energy from renewable sources from the site, then we have the option to go and purchase it off-site. So the second option is purchasing off-site renewable energy. And we can do that by two things, either purchasing green power immediately from a utility provider or purchase renewable energy certificates. So for example, if the energy provider or the utility company does not provide or does not have the option to provide us with green power from renewable sources, then we have the option to purchase renewable energy certificates from international organizations. And those are considered to be an option, which are called RECs. This table shows the credit allocation for this point for off-site renewable energy. Okay. Finally, we're going to talk about the energy performance. And we need to talk about this because if we don't design the building correctly and we don't manage the building equipment correctly, then this will have a great impact on the energy performance and the energy efficiency we talked about in the 3 previous points. So it's important to monitor and track performance over time. Strategies over here include, for example, the first one, which is most important one, is commissioning. So commissioning basically verifies that the building and all of its energy-related systems are planned, designed, installed, and tested, and operated and maintained to perform according to the owner's project requirements. So we have something called the OPR, Owner Project Requirements. So this basically helps us to identify low-cost efficiency improvements and major capital improvements. This process begins with the owner program requirements, which guide the design to provide the basis of commissioning and continues until the building functions as designed and intended. So it's very important to continue monitoring and verifying that the systems we operate and we use in the building are based on what we design and what we built. And we can use different benchmarking tools such as Energy Star and Home Energy Rating System, or short for it is the HERS, H-E-R-S. Okay, so synergies between this category and other categories, we think of the sustainable sites category and the location transportation category. So building design can reduce energy demand. In addition to that, the site design can reduce energy demand. So by doing this, we can think of the integrative approach where if we select something in the sustainable site category or select an appropriate site or smart location, this will heavily impact as a positive impact on the energy section over here. And it's also important, such as the other categories, to think of incentives. Some strategies might be applicable to improve energy efficiency and utilize on and off-site renewable energy, which have a range of public and private sector benefits for owners, occupants, society, and environment at large. So for public sector, we can have expedited reviews and permitting, development incentives, tax credits, tax rebates, technology-based incentives, for example. For the private sector, we can have financing availability, corporate social responsibility, lower risk potential, lower property insurance premiums, and so on. Nowadays, even if I talk from the Saudi perspective, we have different incentives that can come from either the energy utility providers or from the municipalities here. So that's basically it for this category, and I hope the issues we discussed are very clear. Basically, this is a very dense category, but more details can be found on the reference guides. And also, if you pursue for the LEED credential exam, more details can be shown in the candidate handbook and the study guide. 2 example questions over here from the exam. To what do renewable energy certificates refer to? RECs. Okay, you see a couple of answers. Yes, correct. The answer is B, which is off-site renewable energy purchases. So the answer is B, RECs refer to off-site renewable energy purchases. Okay, second question. One of the most cost-effective ways to ensure optimal ongoing energy performance is to what? Okay, so that we can move forward, the correct answer is C, commission building systems. So why is it C? Because the question says optimal ongoing energy performance. So how can we make sure that the ongoing energy performance is at its optimal state and strategy based on how can we make sure the ongoing performance is good? We can only do that through commissioning the building system. Okay, so keeping commissioning the building system throughout the whole life cycle of the building from day one until it's demolished will help me make sure that we have optimal ongoing energy performance. Okay, so that's it for this category. If we have any major questions, or can we take it at the end, Deepti? So let's move on. We have 2 categories remaining. I hope that we can continue. I'm trying to push forward and continue, finish on time. So we have the materials and resource credits, talking about it here. And when we think about it, also think about the logo here. The logo shows us that the recycling logo here, and it's basically something that we will talk about in terms of materials and resources, is try to mitigate the effects of selection and purchasing of material in order to reduce the impact on the environment and on the economy. Some of the points we're going to talk about is basically to reduce the amount of materials needed, use material with less environmental impact. We're going to see that in detail, and reduce and manage waste. So we're still going to have waste, but how can we manage that waste and use that waste to our benefit instead of just taking that waste to landfills and dumping them outside of the site and cause environmental problems. So in terms of the integrative approach, when we think of it in design, so during the construction, LEED encourages the separation, reuse, and recycling of building materials. And during construction, the project should try to separate, reuse, and recycle building materials during construction. Finally, during operation, LEED promotes reducing the flow of materials into and out of existing buildings. And we're going to see that in detail when we talk about the materials in 2 perspectives. We're going to talk about it in terms of waste reduction and materials impact. So let's talk about waste reduction in the beginning. We have 3 R's talking about in terms of the sustainability manner: reduce, reuse, recycle. So the first step we have to apply here is reduction. So reduce waste generation before we even have waste. And if we have waste, divert and reuse the waste. We're going to see the strategies for reducing waste generation. The first thing is we need to establish and or expand the recycling program. So even if we have a primitive recycling program where we just recycle glass, plastic, metal, for example, we need to expand that program basically to eliminate waste going into landfill. And one of the ways to do that is we perform waste audits. Waste audits can be done through different platforms, and basically doing this will help facility managers understand the sources and composition of solid waste in their facility. The data can be used for foundation for designing and improving recycling programs. And the final thing is to practice sustainable purchasing. And this can be done as a policy that outlines procedures and goals for the use of ongoing and durable goods, monitor the effectiveness of use waste reduction policy, and sustainable purchasing can apply to food as well. Strategies to divert uses, for example, over here, when we talk about construction demolition waste, we need to separate them on site and try to use them for the site itself. We can use them for paving the site outside, even crushing them and using them for landscape. And this comes to the point of solid waste recycling. So the first step of successful waste management policy is to reduce the total quantity of waste. This process is easy and often has no cost to the contractor or building owners if the recycling company can keep the material placed in recycle bins. Another example for reducing waste is to actually use factory or prefabrication in framing, for example. In our case, in concrete, we can have precast, prefabricated. We even reach the stage of 3D printing. So all of those practices and techniques can help us reduce our waste before we even generate waste, because we're going to build as per our needs. We're not going to build and use material in excess of what we need. So that's the first point of waste, is to actually have waste reduction strategies. Now, the second point is the material impact. Now, the material impact can have different impacts, either in an economical perspective or on an environmental perspective. So economy and environment. So what we need to do here is to reduce the demand for materials, reuse the materials as much as possible. If we have the option to reuse the building, then reuse the building is the best case scenario. And we talked about it in the sustainable sites category and the location where we reuse an existing building as a brownfield site. Select new materials with less life cycle impact. So what we mean by that, when we think of the strategies to reduce demand for material, we start by the design strategies. So design based on less waste. And also in terms of the design strategies, the construction strategies, how are you going to construct the building? That also has a great impact on reducing the waste. And make benefit of new technology solutions. So even nowadays, we have, as I said, 3D printing and other strategies that are common now in the construction industry markets. Using those techniques can also help us achieve these points. Material reuse is a big bonus advantage over here because we can use, for example, reclaimed, salvaged, and refurbished materials. Also, another benefit or another strategy is to purchase reclaimed or salvaged materials. So the metrics that used here is as a fraction of total materials that can be estimated based on material volume or cost. So the metrics over here we use is for volume or the cost of material that we reuse. The best case scenario, as I said, is to use building as a whole. So this is an example of building reuse. So we reuse the existing building or portions of the existing buildings. Again, the metrics over here can be the amount and percentage of using the building, such as existing walls, floors, roofs, and other materials used in the new instead of new construction. So that's the best case scenario. What we want to achieve by the end is basically try to achieve a life cycle assessment. So we want to do a life cycle assessment of the material. So the life cycle of the material begins over here with the generation of the material itself. So for example, the wood over here from the forests or where the tree grows, we take it, transport it to the manufacturer where it's manufactured, and then goes to the construction site where it's used and constructed the building. The building is used during this life cycle. We try to keep maintaining the building. The normal life cycle ends at this dumpster. So it ends at the landfill. So that's the normal life cycle of a conventional building. This life cycle, we call it cradle to grave. So the cradle is where we extract the material from, and then the grave is where we basically finish the life cycle of. So the optimum solution is to continue using the material through the life cycle of the building for a longer period of times. And that's the concept we call cradle to cradle. In addition to that, we have different examples of responsibly sourced and extracted materials. Over here, we have two concepts which are associated with recycled content. We have post and pre-consumer. These points over here for post and pre-consumer are basically the contents of the material within the material I'm going to use. So for example, imagine this wood bench over here and the marble and everything over here. This material, this cabinet can have contents of the material in it that is considered to be post and pre-consumer. So post and pre is basically from the word itself. So post is after it's being used and pre it's before it's used. So an example of this, when we think of pre-consumer, think of newspapers. Okay, the newspaper, if it's in the store and it's not bought by the consumer, and it gets collected back by the press of that newspaper, that is considered to be pre-consumer. But for example, if the newspaper goes to the user, goes to you in the house, and you read the newspaper, and then that newspaper gets recycled, that's considered to be post-consumer. Same thing for example for plastic water bottles or plastic milk cartons and so on. Also for the material, it's important to have it locally sourced. in addition to having a bio-based material. And if you're going to have wood in the material in the building, make sure that it's certified wood. And we have the FSC certified wood, which is the Forest Stewardship Council. An important aspect over here with the material is basically to disclose. So manufacturers have to have transparency of products in terms of the supply chain, in terms of the ingredients, and in terms of the life cycle impact. So we have the concept that's called EPD, Environmental Product Declaration. This is a document that basically declares to the consumer and to the buyer what impacts in terms of environmental impacts is associated with the material. So this is an example of a flooring carpet, which is from the company name Interface Floor. And it shows you the life cycle impact in different categories, such as atmosphere, water, earth. So selecting a material with an EPD, that's a direct credit in this category. In addition to this, there's another concept called HPDs, or Health Product Declaration. Now, similar to the EPD, this has a declaration or disclosure of what are the potential health effects of the product. Sometimes we have a red list of bad chemicals that we try to mitigate or try to reduce using it in the materials. Manufacturers must disclose what is in their products. You can find more information on the Health Product Declaration collaborative website shown over here. Other strategies for material resource and synergies, basically using recycled material can reduce landfill-related emissions. So you're reducing your impact on the environmental aspect. Sustainable purchasing programs improve indoor air quality. And we're going to see that in the next category. Non-toxic materials have environmental benefits. In addition, we saw these incentives also used in other categories. So it's important over here to also think of incentives and recognition programs either locally or internationally. Okay, so that's it for this category. One question here as an example. What is EPD an acronym for? Okay, good. I see that you're still focused. Yes, the answer is C, Environmental Product Declaration. Great. Okay. This is the final category, which has prerequisites we're going to talk about, and it's very heavily related to the materials section, which is the indoor environment quality. So when you think about it, the indoor environment quality basically can help us improve our lifestyle habits and lifestyle practices and our productivity, basically. And what we need to do is to provide systems to ensure the quality of indoor environment is very good. And we can do that through air quality, thermal, visual, and acoustic comfort. And we basically want to reduce, eliminate, and manage the contaminants indoors. Now, we can do that through the phases of the integrated approach through design, construction, and operation. Due to time being short, I'm just going to try to move on. But basically, the selection of the material, we talked about it previously. We can do it through the design phase. And then when we do the construction, we actually want to control the contaminants during construction and control it by reducing the contaminants spreading throughout the whole building, which will have a heavy cost later on during the operation. So two things we talk about it in this category: occupants' comfort and productivity, and indoor air quality. So for the indoor air quality, we need to design well-ventilated buildings. We need to select appropriate material, reduce or eliminate contaminants, control moisture, promote green construction practices. It's very important, again, here, we saw this information in the sustainable site category. Also, it's part of the energy and atmosphere where we select the building orientation, the building mass to our benefit. So we need to provide sufficient fresh air, and we need to also exchange air regularly for the health and well-being of the occupants indoors. And we can see the credits related to the design well-ventilated buildings over here. where the prerequisite is to have a minimum indoor air quality performance and make sure that that performance meets the threshold listed by the LEED requirements over here. Examples of appropriate material was selecting low emitting material. So we have a concept called VOC, VOC material. So we need to select material with low VOC emittance, which means the emitting coming out of this material during normal practice. So if you have the indoor smells of new carpet, new paint, all of those nice smells we smell in indoors, we want to limit those smells because those are emitting materials. In addition to that, we want to mitigate radon gases. We can also help indoor environment quality being good through cleaning products and selecting green cleaning products. It's also prohibited in LEED buildings to have smoking, so we need to also control tobacco smoke. Entryway systems is another way to make sure that the indoor environment does not get contaminated during daily use. And as I said previously, during construction, it's also important to make sure that the air quality and management plan is in place to help us when we open the building, that we don't have many areas to clean up after the construction. So when we have the construction activity prevention plan in place, that's when we reduce our overall cost later on. In addition to that, it's very important to consider reducing moisture. So we need to cover materials during construction. It's important to direct rainwater away from buildings during construction and after using it. Also maintaining the building envelope and making sure there's no leakage, there's no problems happening with plumbing pipes, and control humidity, because the fungus and effects happening from this can heavily impact our respiratory systems and our health. During construction, it's also important to promote green construction practices, such as protection of construction workers and also preventing damage. Protecting of human health include use green cleaning products, avoid toxic paints and sealants, and we can also make sure that the toxics and sealants, we have toxic paints and so on, are regulated by third-party verification systems such as Green Seal, Green Label, and Green Label Plus, and so on. Okay, the final thing we're talking about here is occupant comfort and productivity. So we want to control thermal comfort by providing an appropriate, comfortable environment for people to be productive in. And we can do that, for example, through providing daylighting and views. Consider acoustics is very important to make sure that the building is soundproof and also make sure that the occupants don't get disrupted by noise from outside or from inside. Lighting satisfaction is also important. We're going to see that. So in terms of thermal comforts, it's very important to have user control. So the users, if they have control over the thermal comfort, they can be productive in their own buildings. And it's also important to monitor performance and make sure the building is performing as per the design and construction phase. And we can do that through different standards. ASHRAE is one of the prominent standards we use in this category. Just a schematic sketch to show you the different strategies to provide daylighting and views. Some functions have the option to have direct views and daylights from the exterior spaces, but interior spaces sometimes don't have that privilege. So we need to design something to mimic natural daylight through skylights, through sun tubes, and so on. For schools, it's a prerequisite to consider acoustics. So acoustic impacts, reduce interior noise transmission is a must, is a prerequisite in schools. Otherwise, in other building types, it's a credit. You can see this over here in schools. It's a prerequisite to have a minimum acoustic performance. Lighting is also important to increase productivity of occupants. So you need occupant lighting control for each individual as much as possible. Also, regulations and incentives is very important to consider, either local regulations or international regulations. Okay, so that's it for this category. A question here as an example, I told you about this very briefly. The abbreviation of VOC refers to VOC. Okay, the answer is B. Okay, volatile organic compounds. Another question over here. Thermal comfort is typically attributed to what environmental factors? This might be a tricky question because we didn't really stop in detail on it, and it's really there in the reference guide for the LEED study exam prep work. But basically here, when we talk about thermal comfort, the three attributes are in the A selection, okay? So ASHRAE standard 55 defines environmental factors of thermal comfort as temperature, humidity, and airspeed. So the answer for this question is A. Okay, the final thing we're talking about here is basically the bonus points. So with the environmental quality category, we finished 100 points for the LEED system. We have an additional bonus 10 points for innovation and design and regional priority. Innovation and design have 6 bonus points, and regional priority have 4 points allocated for them. So basically, what is innovation design? It basically recognizes exemplary or exceptional green building performances, and it rewards practices that the LEED rating system does not specifically address. So if you applied something to the building which is not specifically addressed in LEED, or which are the topics we talked about through this session, then that's something that's considered to be innovation. And that can happen through design, construction, or operation. And there's many different examples that we can talk about. And we talk about here basically 3 aspects under this category. Either it's exemplary performance or innovation in performance, or even having a LEED AP on the team or in the project can also be allocated a point for it in the credit system. So a LEED AP on the project team can have a point in it. I'm going to show you some very brief examples over here. One of the case studies in this, for example, Charlottesville Transit Center, they used a section of the building to be an education center or education section where people can see how the building got certified or what are the sustainable strategies they used in the building. So that's something innovation in the buildings that can be used credits for. Another example in this building is where they use also this section of the building for education purposes, and they show the people how energy conservation and how different water systems are being used in this building. So this is, again, one of the innovative solutions is education section in the building. Another example over here in this picture is the selection of the material in this building actually exceeds the limits of what is explained in the LEED certification system. So exemplary performance is applied over here. This tower, for example, again, it exceeded the requirements for what is addressed in the LEED system, and also has different strategies to reduce the overall consumption of energy, even though you might see it as a glass facade, but the system that they used is very innovative, and they got points for that. So that's basically it. This is an example question that comes in the exam. An innovation and design credit for exemplary performance would be available for okay, due to time constraints, the answer is B, which is significantly diverting construction waste beyond the requirement of 75%. Now, the reason this answer is B, because of basically we are exceeding the requirements for LEED, which is beyond the 75% for construction waste diversion. So that's basically it. We talked about this in detail for each category. I hope the description and analysis of all of the categories are clear. Many times that we discuss this in detail, we talk about also the regional priority. So just as an example, I'm going to show you a few case studies from Saudi. We have the KAUST University, which was LEED certified as platinum level. The Middle East, the first LEED platinum was the single family home in Sabiq compound, which is the home of innovation house. Another example is the Kapsark Research Institute in Riyadh, which also got LEED platinum. Princess Noor University in Riyadh also LEED gold. In addition to this, you can find many information available to you on website where you can find information on different projects that have been disclosed by the owner of the project. So this is an example of Fadli Admin Complex. The website is GBIG, Green Building Information Gateway. In addition to that, regionally also, the Dubai Chamber of Commerce got the LEED Platinum in 2018, which was using the updated system of LEED operation and maintenance. The High Bay Building Dubai Silicon Oasis Authority, which is targeting LEED Platinum for V4.1. So this is the website. You can get more information on different buildings, which is the GBIG, Green Building Information Gateway. I showed you this yesterday as well. These are the documents that you need to acquire to study for the exam. So the first one is the LEED Core Concept Guide. The second is the LEED Green Associate Exam Preparation Guide. In addition to that, the candidate handbooks have been updated and you can download them for free. There's also an Arabic version if you want to study it in Arabic also. And for the candidate handbook for the AP as well has been updated and it's available for you to download it on the website. So more information can be found on the website, either for the reference guides or for the education platform, where you can also subscribe to get more information and get more sessions you can have. Please take a screenshot for this because these are the USCBC faculty that can be approached, and they can help you also guide you through the more detail in terms of credentialing preparation. One of the USCBC faculty actually has approached with a schedule who is Muhammad Fikri Abdul Ghafoor, and you can reach him through his email and also the emails over here with the USCBC faculty in the GCC and the Middle East region. So please contact them, and also you can reach out to us, myself and Deepti's email, if you have any questions or any inquiries. Thank you very much. I hope that all information is clear, and please send us all of your information if you want any questions. We are happy to assist you in that. I know we are 2 minutes over time, but now if you have any questions, we'll be welcome to address them. So, Deep, do you have any questions, or can we conclude?
No, there was just one question on the exam. How does one register? So I think that's something we can send out in our email to all participants with the link. We can actually send them a link to our website and where they can go and register for the LEED GA exam. We can also send some resources. What do you think? Like the toolkit, we can share some resources with them, no?
Yes, definitely. There's a detailed email we can send, and there's going to be a study guide also. You can download it from the website. I'm going to share details on it and the links for the different documents.
Perfect. I think that was the only question, and there was some questions on water metering in Saudi. But if there's a specific question, then please reach out to us, and then we can address it offline. Thank you.
Okay, thank you very much for all attendees, and we hope to see you in other sessions. And please contact us for any information. Thank you all.